talking about how we present data in tables and charts. And thereafter, we will discuss about how so we will present and summarize our data using some numbers that we estimate from the data. Okay, right. So here are the learning. So what you learn from this class. So we will be talking about how to develop tables and charts for categorical data, and how to develop tables and charts for numerical data, and the principles of properly presenting graphs. So this is what we will be learning. And you know what is categorical data now. So what is numerical data? All these things are pretty much understood to you. අපි කලින් ක්ලාස් එකේ කතා කරා. ඒ නිසා ඔයගොල්ලෝ මේවා ගැන දන්නවා කියලා මම assume කරනවා. Okay. Now, so this is the way how I have outlined the presentation today. And so I will be talking about data in raw form, right? So which are usually not easy to use for decision making. So then we need to organize them somehow, maybe in a table or in a graph. And I will be talking about how things are presented in a table and how they are presented in graphs. So following are the next I have listed out the graphs that we will be talking about: bar charts and pie charts, Pareto diagram, ordered array, stem and leaf display, frequency distribution, cumulative distribution, contingency table, and the scatter diagram. So this is what we will be talking about. Right, this is our understanding, right? The categorical data. For the categorical data, so we will use tables and some sort of graphs. අපි categorical data වලට පාවිච්චි කරන graphs සාමාන්‍ය numerical data වලට පාවිච්චි කරන්නේ නැහැ. මේක තමයි අපි පාවිච්චි numerical data වලට පාවිච්චි කරන graph අපි categorical data වලට පාවිච්චි කරන්නේත් නැහැ. ඒ එක එක data වල හැටියට තමයි අපි display කරන tool එක decide කරන්නේ. So this is the reason why we learn this chapter, right? So that's the reason why we specifically talk about what are the different tools that we use to summarize categorical data. So we will be tabulating them in summary tables, and we will be graphing them using bar charts, pie charts, and Pareto diagrams. So these are specially developed for categorical data, not for continuous data. You need to understand this pretty well. I hope it makes sense. Right? Any question? Right? All right. So coming on to the tables, suppose, right? So we have some data on investment. So the different people, right? Different people will invest on different things. So in the right, so we may have collected the investment patterns of different people who will invest on different things: stocks, bonds, right, and different certificates, right, and the savings. So these are the different types of that where people invest money. Right? They are categorical variable. Then we can present the investment by categorical variable. How many? So what would be the amount that the people have invested by different types of different types of investments, and what would be the percentage of investment? So by looking at this, you will see that the most of the most right of the money has been invested on stocks. Then the stock is the stock market, right? The stock is most famous among the people as an investment portfolio, right? It shows us, right? So what would be the best one to invest by someone else, right? Okay, right. Similarly, right? Similarly, so you can do a lot of things, right? You can do many things. Okay. Suppose we have collected gender data. We have suppose collected gender from a work community, right? Our example, our variable is X. So we may have female, male, male, female, 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 male. Likewise, so this may be right entered, right? There may be, right? Say the sample size is right is 1,000. So you have collected gender of 1,000 persons. And so this is the way how you have outlined, how we have entered your data. So just looking at the data, so we will not be able to understand how many male are there, how many female are there, unless you summarize them in a table. Then you can count males and females, which is called, so it is called frequency. අපි එකට කියනවා frequency කියලා. How many times male appear, how many times female appear. Say, right now we can put this data in a table, right? We can draw a table, right? And it is something like that with two columns. Gender. So this is the variable gender. We have female, we have male, and we can record the frequency. We can record total frequency, right? Say we have 450 females and 550 males. And we can, right, present them as a percentage, right? This is 45% and this one is 55%. The majority of the sample is male, right? So this is the way how we can tabulate things in a table. So we can use tables to summarize our data in different ways. Is it clear? Right? Okay. Now, so we will try to understand how we summarize data using graphs. How to summarize can display data in graphs. Graphs are pictures, right? They are pictures. Okay. Right. The first type of graph that I'm going to introduce is bar and pie charts. Right. We will in a right, bar and pie charts are often used in qualitative data, the categorical data or the data in nominal scale. The height of the bar or size of the pie slice shows the frequency or percentage of each category. You can present, right? You can present this, right, gender data using a chart, pie chart or a bar chart. The size of the bar, the height of the bar or size of the pie slice shows the frequency or the percentage of category. So this is the pie chart, how it looks like, the bar chart. bar chart එක මේ අතර තිබ්බොත් අපි කියනවා මේකට horizontal bar chart. හරිද? bar chart. මේක අනිත් පැත්තට අපි ඇන්දොත් එimhe අපි ඒකට කියනවා column chart කියලා. අපිට මේ පැත්තටත් අඳින්න පුළුවන් amount. right? sorry. amount ගන්න ඕනේ අනිත් පැත්තට. right? class amount. අපිට මේකෙත් අඳින්න පුළුවන් මෙහෙම. මේ විදිහට අඳින්න පුළුවන්. amounts. right? පාට කරලා ලස්සනටනේ. so you can do it like this. right? This is savings. This is CD. This is bonds. And this is stocks. right? ඕනනම් අපිට මේවා මේ විදිහට amount එක දාන්නත් පුළුවන්. එහෙම නැත්නම් percentage එක දාන්නත් පුළුවන් ඕනනම්. if you want. right? instead of amount we can use percentages. මේ තියෙන්නේ මේකයි ඕනනම් පාවිච්චි කරන්න පුළුවන්. right? this is it. so this is the way how it looks if you put that in a pie chart. the pie is a circle, right? pie කියලා කියන්නේ කෑමකුත් තියෙනවා pie කියලා නේද? pie එකක් round. vegetable pies තියෙනවා, chicken pies තියෙනවා, එතකොට sweet pies තියෙනවා. so different things are there. right? please give me a little bit right time. මේ විදිහට තමයි අර bar chart එකේ පෙන්නපු data pie chart එක පෙන්නන්නේ. right? අපිට percentages විදිහට දාන්න පුළුවන්. මේ විදිහට bar chart එකෙත් පුළුවන් ඕනනම් ප්‍රමාණය දාන්න. pie chart එකෙත් පුළුවන් ප්‍රමාණය දාන්න. but usually a pie chart will be more meaningful when we present them with the percentages. okay? The next diagram that we talk about is the Pareto diagram. The Pareto diagram is a combination of a line chart and a bar chart. Okay. Before we talk about Pareto diagrams, let me tell you some more information, some more useful information. Okay. Frequency. The one term is frequency. Of data. What does it mean by frequency of data? Say we have a variable, say, right, x is weight of chicken. Then x can take many values. 1, 1.5, 1, 2 kilograms. Right? In kilograms, say in kilograms. 2.2. Right? 3, 2.5, 3.3, 2.5, 1.5, right? 1, 1.5, 2, 2, 3.0, Let's say 3. No, 0, right? 3 and 2.4. So likewise, we have data. Or else, in the case of and 0.7, 0.5, 0.9. කොහොම ඉන්න පුළුවන්. The frequency is the number. Wait. I got a wrong example. No. මේ example එක මෙතෙන්ට අරන් බෑ. Right? අපි categorical data වල example එකක් ගමු. Number of accidents. Number of accidents ඕනෙත් නෑ ගන්න. ඒක categorical data නෙමෙයි. Education level. Then X can take low education, medium education, and high education. එහෙම නැත්නම් අපිට මෙහෙම ලියන්නත් පුළුවන්. Right? Okay, මෙහෙම ගමුකෝ. හොඳයි. Then we collect data, right, from different peoples. Low education, high education, medium education, low education, medium education, medium, high, low, medium, high. How many people? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. විස්සක් ගමු. Low, 14, 15, 16, 17, 18, 19, 20. Our sample size is here, right, 20. The frequency is, right, how many times each outcome of the variable is repeating in the data set. අපි ගත්තොත් එහෙම, so this is the class, the category. So we have low education, medium education, and high education. The frequency is the number of counts. How many low? 1, 2, 3, 4, 5, 6. We have 6 low education people. And medium, 1, 2, 3, 4, 5, 6, 7, 8. 8 people. Let me make this also median. Right? This also median. Then this will become 9. High, how many high? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6. All right. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Right? 20 is now okay. Right? 20 okay. Let me put this is medium. Now we have 1, 2, 3, 4, 5. We have 5 here. So this is the frequency. And we can estimate something called relative frequency, right? අපිට estimate කරන්න පුළුවන් another number which is called relative frequency. Relative frequency. Relative frequency equals frequency divided by n. Then in our data class, we have low, medium, and high. So we have reported frequencies 6, 9, and 5. Relative frequency is 6. The total is 20, right? 20 and 9 divided by 20 and 5 divided by 20. So this equals, how much is it? Right? How much is it? 0.3. So this is 0.2. This is 0.4, right? This is 0.25, right? This is 0.25. 0.25. Sorry. I made a mistake. 0.25. Then this is 0.55. 0.45. And this would be the frequency. Right? So these are the frequency. Right. And there is another concept which is called cumulative frequency. So that is the sequential summation. This is of frequencies. The class here, low, medium, and high. Right? Then frequency is 6, 9, 5. Cumulative frequencies, the cumulative frequency of first category is the same value, these 6. And the cumulative frequency at the level medium, so we add 6 to the 9, this is 15, and this is 20. We add 5 to 15, this is 20. So this is total 20, right? Right. So similarly, we can compute relative cumulative frequency. That also we can do. Okay. All right. So with this knowledge, we will talk about Pareto diagram. Any question after this? මෙතන නිකන් ප්‍රශ්න තියෙනවද ඔයගොල්ලන්ට? මොනවා හරි? Anybody who has issues? Any problem? Any question? කාටවත් ප්‍රශ්න නැද්ද? දැන් මම මෙච්චරලා උගන්වපු එක තේරුණා නම් විනාඩියක් දෙකක් අරගෙන තේරිච්ච අය එක දාන්න නැති අය බින්දුව දාන්න chat box එකේ 51ක් ළමයි ඉන්නවා I expect 51 responses අමාරුවෙන් එකක් වැටුණා පන්තියෙන් භාගයක් තමයි අහගෙන ඉන්නේ කියලා මට පේන්නේ හරියටම 27 දෙනෙක් මට රෙස්පොන්සස් දීලා තිනවා අනිත් අය අහගෙන නැහැ වගේ තමයි මට පේන්නේ okay let me check what they have said all right the feedback looks good okay no zeros I hope you have understood. Okay, well, very good. Okay, with this understanding, let's talk about Pareto diagrams. The Pareto diagrams are used to, right? So they are used to display or they are used to summarize categorical data. So which are in nominal and ordinal scale. So mostly the nominal scale data. So this is a bar chart where categories are shown in descending order of frequency. අපිට බාර් chart එකක් සාමාන්‍ය බාර් chart එකක් අඳිනකොට අපිට ඒකේ තියෙන frequencies අපි ascending descending order එකට arrange කරන්නේ තියෙන විදිහට තමයි කරන්නේ. හැබැයි in a Pareto diagram so we will organize right the classes the categories in ascending order considering their frequencies. So thereafter, we will incorporate a cumulative polygon on the same graph. So this usually used to separate the vital few from the trivial many. A Pareto diagram is mainly applied in quality control studies. So especially when we want to the understand the most possible root cause of defects of your products. So we will construct a Pareto diagram, right? Okay, the Pareto diagram looks like this, right? This is the bar chart. Maintain a bar chart, right? Bar chart. So this is the bar chart. Okay, this one is bar chart. The bar chart. Bar chart. So we sometimes use the percentage or relative frequency or else frequency. Anything can be used in the y-axis. In the x-axis, you have categories. You have categories in the x-axis. This is the x-axis. So we have two y-axis. So this is here we get cumulative percentage, cumulative frequency, or cumulative relative frequency. This is what we get into the second y-axis. So which is on the cumulative polygon. The cumulative polygon is depicted in a line. We can connect this here, right? So this is a cumulative polygon. Or else we can connect it. Oh, it is not working. So this is cumulative polygon, right? Now you can understand that, right? So which is the most popular type of investment portfolio, and how many people have invested on both the stocks and the bonds, right? So how many people have invest on least famous type of investment mode? So likewise, so we can make many inferences. So based on the Pareto diagram, for an example. In addition to this, right? In addition to this, if you go and see in Excel, අපි Excel වලට ගිහිල්ලා බැලුවොත් අපිට categorical data display කරන්න තව විවිධාකාර වූ, right? විවිධාකාර වූ ඒවා තියෙනවා. right? එක එක જાතියේ charts තියෙනවා. මම ඕගොල්ලන්ට ඉන්න share කරන්න. මම Excel sheet එකක් share කරන්නම්. right? කොහොම ඉන්න. Let me share one Excel sheet. අපි Excel sheet එකකට ගියොත් අපි මේකේ අපි ගිහිල්ලා insert කියන තැනට ගියාම අපිට මේ graph chart ගොඩාක් පෙන්නනවා මෙයා. මේ තියෙන්නේ මේ එක එක જાතියේ bar charts තියෙනවා. මේක ඇවිල්ලා අපිට හැම වෙලේම තියෙන්නේ ඔය categorical data display කරන්න තමයි. එතකොට අපි pie chart වලට ගියාම we have different kinds of pie charts like this. And these line charts, මේ bubble charts, මේ line charts උත් ඒව තමයි. මෙන්න මේ chart එක සාමාන්‍යයෙන් අපිට bar charts වලට පාවිච්චි කරන්න පුළුවන්, categorical data වලටත් පුළුවන්. ඒව නැත්තම් mostly as categorical data. So this is for the Pareto diagram. මේකෙන් අපිට Pareto diagram එකක් අඳින්න පුළුවන්. right? okay, ඒ වගේ ගොඩක් option තියෙනවා Excel වල. අපිට එක එක જાතියේ ඒවා අඳින්න. මේ තියෙන එක එක જાති charts column charts තියෙනවා bar charts තියෙනවා line charts pie charts මේ line chart කියන එකත් අපි සාමාන්‍යයෙන් අදින්නේ categorical data වලට. එක එක જાතියේ line charts තියෙනවා. මේ XY කියනවා අයව පස්සේ කතා කරමු. ඒවා අපි ඒ විදිහට කතා කරමු. right okay. ඒ වගේ different options තියෙනවා. Okay, this is what we were talking about, right? Okay, let's talk about so what are the options that we have to display, that we can display the numerical data, tables and charts for numerical data. So we have ordered array and the stem list display, right, to depict numerical data. We have frequency distributions and cumulative distributions, so which are usually depicted by histograms, polygons, and ogive. In addition, we have XY, right? XY scatter diagrams, time series plots, right, for numerical data, to present the numerical data. Okay, first we will try to understand what is an ordered array. This is none other than, right, what you have learned in your O-levels. O-levels, a sequence of data in rank order. We can rank them in ascending order or descending order. So it shows the range, minimum and the maximum, and it provides some signals about variability within the range, and it helps us to, right, identify outliers. And if the data is too large, the data set is too large, the ordered array is less helpful. ordered array එකක් පාවිච්චි කරන්න පුළුවන් data set එක පොඩි එකක් නම්. හැබැයි ඒක ලොකු නම් අපිට ordered array එක පාවිච්චි කරද්දී ටිකක් ප්‍රශ්න ඇති වෙනවා. Right? Right? So with small data sets we can use ordered array, but with big sets of data, ordered array would not much useful. Right. So this is a set of data that we have collected, and so these data are ordered from smallest to large, right? 21, 24, 24, 26, 27, 27, 30, 32, 38, 41. So they are in the ascending order. So we can do it on the other way as well. Descending order එකටත් අපිට කරන්න පුළුවන් ඕන නම්. Right. Okay. Now I will give you 5 minutes break, and thereafter we will get back to the discussion. So this is a simple way of seeing the distribution details of a given set of data, right? And the method that we use here is we separate the stored data series into leading digits, so which is taken as the stem, and to the trailing digit, so which is taken into leaves. Okay, let's take an example and see how we could understand this, how to do this. Okay, this is our set of data. In this set of data, the leading digit is this, and the trailing digit is this one. So we will take the leading digit. We will take the leading digit into the stem and the trailing digit into the leaf. It says now 25, 21. The 38 is depicted like this and 41 is depicted like this. Okay, let's see how we can arrange all of this data in a stem and leaf diagram, right? So these are the leading digits, right? Now we have 20 is 21, it is 1, 24 two times, 26 again, 27 two times. So we have 6 20s here and 3 30s here and 1 40s. And it says that, okay, well, so we have more 20s, more 20s, more 20s, and right, some 30s and few 40s. Okay, I hope it makes sense. So this talks about the distribution of the data. So if we have, right, so big digits, hundreds in this case, we have 100 as the leading digit, and we get 100 as the leading digit, and tens, so this as the trailing digit. And so we will curtail rest of the data. We will lose the rest of the data in the step and leaf diagram. අපි මේ වගේ data set එකක දැම්මොත් මේ වගේ data set එකකට දැම්මොත් ඒක පේන්නේ මේ විදිහටයි. 613 is depicted in the stem and leaf diagram as 610. 632 is given here as 630. 658 is given here as 660. Right? So this is how it is depicted here. Okay, what does it mean by distribution? What does it mean by distribution? What is distribution? Data. We can talk distributions. We have distributions right for categorical data and continuous data. So, right, so we have things for categorical data and continuous data. So here, so we talk about continuous data, the distributions of continuous. The distributions tells you, so this tells you how likely right each outcomes of a variable can occur, right? Distributions tells you how likely each outcome of a variable can occur. කොච්චර chance එකක් තියෙනවද? අපි මෙතෙන්ට ගිහිල්ලා බලපුවාම පේනවා 20s අපි මේ sample එක දිහා බලපුවාම 20s ඒ population එකේ 20s හම්බෙන්න තියෙන chance එක වැඩි 30s වලට වඩා. 30s හම්බෙන්න තියෙන chance එකට වඩා 40s හම්බෙන්න තියෙන chance එක අඩුයි. So this is what it says, right? By the distribution of a set of data. Okay. So let's talk about tabulating numerical data by means of frequency distributions. So I explain you what is a frequency distribution, right? Frequency distribution එක කියලා කියන්නේ මොකක්ද කියලා මම ඔයාලට දැන් මෙතන කියලා දීලා ඉවරයි. Okay, now you know it. So it's a list or a table that contains class groupings, right, corresponding to frequencies, right, with which the data fall in each grouping or category. So this frequency tells you how likely each and every observation appears. So if you draw random samples. Okay, why we use a frequency distribution? It is a way to summarize numerical data, and it condenses the raw data into a more useful form, and it allows for a quick visual representation of your data. And it tells you further how likely so different classes of right data can happen, right? So this is the usefulness of a frequency distribution. Okay, let's see how we can get the class intervals. So first we need to understand the class boundaries to define the class intervals. So each class groupings has the same width, usually in a frequency distribution. We will define first the width of the interval. So we will first, to get this, we will divide the range of our data from the number of classes, number of groups that we want to have. And usually we will, set number of groups from 5 to 15. And remember that for continuous data, class boundaries never overlap. And usually we round up the interval with to get desirable endpoints. Okay, let's see how we can do it. Okay, this is an example. A manufacturer of insulation randomly select 20 winter days and record the daily high temperature. So what you have here is daily high temperature. And in this context, I have stored the data in ascending order. This is the ordered array. The first number that you see in an ordered array in descending order, right? In ascending order, the first number is 12, so which is the minimum. The last number is the highest number, so which is the maximum. The difference between minimum and the maximum is the range. And in this context, the minimum is 12 and the maximum is 58. The difference is 46. Suppose we want to have 5 classes, right? And we will divide 46 by 5. And 46 by 5. Then we will round it up. We will round it up to 10. Right? 46 up with the poem 9 point something. එතකොට අපි ඒක 10ට වටේනවා. ඉහළ නම්බර් එකට තමයි වටේ යන්නේ. Right? 9.9.9.2. Right? 9.2 අපි පල්ලෙහාකට වට යන්නේ උඩේකට වට යන්නේ. එතකොට අපි rounding it up to the upper number. So now it is 10. So now our class boundaries are right 10, 20. So this is the upper boundary. 10, 20. Actually, this is the upper boundary. So this is the upper boundary. 10, 20, 30, 40, 50, and 60. So now we can compute the class midpoints. So they are 50, 20යි 10 අතර තියෙන 15 මැද point එක 10යි 20යි 30 අතර 25යි. So likewise we will get the midpoints. Right? We have 5 classes where we have 5 midpoints. So now we will count the number of data. So that lies between, right? So these classes. So that is 10 to 20 is 1, right? Right, 20 to 30 is another one, 30 to 40 is another one, 40 to 60 is another one. Right? Okay. Right. This is the way how we do it. Then, so take a look at the classes. 10 but less than 20, the first class. 20 but less than 30, the second one. 30 but less than 40 is the third one. 40 but less than 50 is the fourth one. 50 but less than is the 60 is the last one. So we have 3 in the first class. The second class, we have 4 in the third class, 5 observations, and in the fourth class we have 4 observations, and in the last class we have right 2 observations. 50 ඉඳන් 60 වෙනකන් තියෙන්නේ හරිද 53යි 57යි විතරයි. So we can estimate relative frequency and the percentages which we learned before. So with this, so we can right, we can draw some graphs. අපි මෙහෙම ඇන්දොත් graph එකක් අපි එකට කියනවා histogram එකක් කියලා. Right? ඒක class boundaries overlap වෙන්නේ නැහැ. Right? Horizontal axis with classes ගන්න, vertical axis with frequency, relative frequency percentage ගන්නවා. අපිට class boundaries overlap වෙන්නේ නැහැ. අපි histogram එකක් ඇන්දාම මෙන්න මේ විදිහට තමයි තියෙන්නේ. Right? හැබැයි frequency plot එකක් ඇන්දොත් categorical data වලට class boundaries මෙහෙම join වෙන්නේ නැහැ. ඒවා disconnected. හැබැයි දැන් අපි මෙහෙම ඇන්දොත් එහෙම අපි discrete variable එකකට male female frequency ඇන්දොත් එහෙම අපිට female ලා ඉන්නවා 45ක් and male ලා ඉන්නවා 55ක්. Right? Okay. Female, male. So this is a frequency plot for categorical data. It also talks about the distribution, but the bars are disconnected. අපිට bars තියෙනවා ඒකේ. ඒ තියෙන bars ඔක්කොම disconnected. මේ bars disconnected. මේවා disconnected. හැබැයි අපිට histogram එකේ ඒවා disconnect වෙන්නේ නැහැ. ඒවා connected because they are continuous data. All right. So the second other one is the frequency polygon. අපි class midpoints අරගෙන frequencies දාලා මේ වගේ line chart එකක් ඇඳාම අපි ඒකට frequency polygon කියනවා. ASE cumulative frequency polygon කියලා කියන්නේ අපි cumulative frequency එක ඇඳුත් එමු line chart එකේ මේ විදිහට පේන්නේ. ඒකට කියනවා අපි cumulative frequency polygon එකක් කියලා. So similarly we can tabulate them, right? Okay, so now so this is all about the representing numerical data in figures, and next we will talk about how to tabulate, you know, and graphing multivariate categorical data. Suppose we have 2 categorical data. One is the investment category and the second one is the investors. එක investors ලා එක portfolio එක වල දාන විදිය වෙනස්. එක investors අතර තියෙන එක portfolio. අපි එක investors ලා කොච්චර ප්‍රමාණයක් අපි මෙහෙම අපිට දාලා තියෙනවද කියලා බලන්න අපි මේ වගේ table එකක් අඳින්න පුළුවන්. අපි මේකට කියනවා contingency table එකක් කියලා. contingency table එකක් සාමාන්‍යයෙන් two-way contingency table තමයි අඳින්නේ variable දෙකක් තියෙනකොට. So this kind of a table is called contingency table. So we can tabulate that, right, in a bar chart like this, right? For different investors, we can draw side-by-side bar chart. ඒ වගේම මේ වගේ column chart එකකුත් අඳින්න පුළුවන්. මම ඔයගලන්ට Excel sheet එකේ පෙන්නනවා. In addition, we will use scatter diagrams to show up the relationship between 2 continuous variables, right? So this is called scatter diagram. And the time series plot is a plot where we take the values in the y-axis and the time in the x-axis. So this is called time series plot. Right. So so these are the guidelines for a good graph. So we do not distort the data, right? We avoid unnecessary domains. So chart junks are not there, and use we usually scale for x and the y axis as it is required. The vertical axis should be begin at 0. We need to properly label axis, and the graph should contain a title, and we use simplest graph for a given set of data. So this is all about what we will be talking about, the graphical summary measures. So we will be talking about numerical summary measures next. After 3 minutes break, විනාඩි 3ක break එකකට පස්සේ අපි කතා කරනවා ඒ ගැන. Now, so take a look at this. This is the real number line. Real number line. Here you have 0. At this end you have positive infinity, and here we have negative infinity. So whatever the data that we get, right, can put on the real number line. We will compute the numerical summary measures only on continuous data. We will compute, right, numerical summary measures on continuous data. We can put numerical data on the real number line. Right? අපි හිතන්නකො data set එකක් ගන්නවා කියලා. අපි දැම්මොත් අපේ data මෙහෙම තියෙයි number line එකට. Right? We can show our data. Right? So likewise, we can show our data on the real number line. This is our data set. This data set position on the number line on the center. They position on the number line center. So this data set holistically can position on the center. And so it will spread on the number line in a certain distance. So then we can describe a set of data, right, talking about the center and the spread. Right? We can talk about, right, the center and the spread to describe the whole set of data. Right? So there are measurements that we can measure the center. Okay, let me erase this. We can measure the center, can measure. Not only center, but also the spread. All right. So by looking at measurements, right, the measures of center and the spread of the data, you can talk about the whole data set without taking individual data points into the consideration. So this is the way how we summarize data. The measurements of center and the spreads are the numerical summary measures. In simple terms, වැඩිය ලොකු saying නෑ. Okay, let's talk about, right? All right, so we can summarize data. We can summarize data by indicating measures of center and the measures of spread. They are respectively, right, called measures of central tendency and second, measures of dispersion. Central tendency. So that we measure about the center of a data set, right? Measures of dispersion. So that is talk about the measures of spread of a given set of data. We will take the measures of central tendency and the measures of dispersion one by one and try to understand what they are. The first measure of central tendency is mean. Second that we talk about is median. And third that we will be talking about mode. Right? So we will take one by one. Mean. So we talk about two things, population mean. So we use the symbol mu. Say we have estimated our data from 1 to n, right? Okay, let me put it like this. We have estimated, we have taken xi. Xi ranges from right. So we are I, right, ranges from 1, 2, 3 up to n. N is a population size. Right? X can take values x1, x2, x3 up to xn. So this is the total population. So then we estimate mu taking summation xi, I equal to 1 from capital N divided by capital N. This is none other than x1 plus x2 plus xn divided by capital N. So this is called population mean. So which is a parameter that we know. The second thing that we talk about is sample mean. Right? We collect data, a population using a sample of size n. Then our data will look like x simple n. So sample mean is denoted by x bar. Then the x bar equal summation xi, I equal from 1 to simple n divided by simple n. This is none other than x1 plus x2 plus x3 plus xn divided by simple n. This is very easy, right? This is very easy, not very difficult. Suppose our data looks like this: 5, 2, 7, 1, 6, 4, 3, 2, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. And again 10. So in this context, the sample size is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 10. So we can estimate x bar as, right, 5 plus 2 plus 7 plus 1 plus 6 plus 4 plus 3 plus 2 plus 10 plus 10. 20, 25, 29, 35, 36, 43, 45, 50, right, divided by 10. So this is 50 divided by 10 equals to 5. So this is the mean of the sample. This is sample mean. So this is our data set. The next measure of central tendency is the median. Right? The median is the data point so which is at the right middle when data is ordered either ascending order or descending order. Right? අපේ data set එක තියෙනවා නම් අපේ data set එක තියෙනවා නම් x x1 x2 x3 up to xn අපිට ordered array එක ගන්න පුළුවන් x1 x2 x3 xn. So this is the ordered array. මේකේ මැද තියෙන number එක තමයි median එක කියලා කියන්නේ. So right, so the process of estimating median is like this. The first one, right? Order your data. Second, identify, estimate. Place of median. Identify the median. So these are the three steps of doing right estimation of your data. Okay, this is our data set. This is our data set. Okay, now we convert this into an ordered array. The lowest number is 1, the second lowest is 2, then we have again 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 10, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 data. Now the step 1 is done. The step 2. Position එක හොයන්නේ the position of median. So that equals, right, n plus 1 divided by 2. In this case, n is 10 plus 1 divided by 2 is 5.5. This is the first place. First place, second place, third place, fourth place, fifth place, 6, 7, 8, 9, 10. 5.5 is in between this. මෙයා තමයි 5 වෙනියා. මෙයා තමයි 6 වෙනියා. එහෙනම් මේ දෙක මැද. Then in the third step, we estimate it, right? Median is 4 plus 5 divided by 2. ඒ දෙකේ මැදනේ නේද? 4.5. This is the median. Right. The next measure of central tendency is mode. This is the most frequently appearing value observation in the sample. Sometimes there may be no mode. හැම එකම විදිහට આવොත් mode එකක් නැහැ. Sometimes one mode, sometimes two mode, sometimes more than two modes. So this is called a unimodal dataset. This is called bimodal. This is called multimodal. Okay, let's take a look at our set of data. Right? Okay. And see the ordered array. And we will have the ordered array here. This is the ordered array. So if you put things in the ordered array, you can see that 2 is appearing 2 times. And in the same time, 10 is appearing 2 times. Now the mode is 2. Right? So there are 2 modes. 2 and 10. Two times. Mode 1 equal to mode 2 is equal to, there are 2 modes, right? So this is the way how we estimate the mode. Sorry. Yes, mode. Yes, the mode, right? So this completes talking about how to estimate the central tendency. Next, we will talk about how to estimate dispersion. Right? So this measures the spread. එහෙම නැත්නම් අපි කියනවා මේකට variation of data. කොහොමද අපි variation of your data, spread of your data is estimate කරන්න කියලා බලන්න ඕනේ. Right? We'll be talking about many measures of dispersion. The first measure of dispersion that we talk about is, right? The first measure is range. We define the range as, right, maximum minus minimum. අපේ data set එක ගත්තොත් එහෙම අපි අපේ data set එක අපි ගත්තොත් එහෙම පුතා මෙන්න මේ විදිහට තමයි තියෙන්නේ. right? අපේ data set එක අපි ගත්තාම it looks like this. okay? අපි අපේ data set එක ascending order එකට දැම්මොත් we will identify this value as the minimum while we identify this the last value as the maximum. Then minimum of x is 1 and maximum of x is 10. Then we define range equal minimum maximum of x minus minimum of x. This equals 10 minus 1 equal 9. This is the range. The problem is the range is sensitive to outliers. Problem. Range is sensitive to outliers. What is an outlier? What is an outlier? An extreme variable. Value compared to values in the data set. Data set එකේ තියෙන අනෙක් value වලට වඩා extreme value එකක් තමයි අපි පාවිච්චි කියන්නේ. අපි මෙහෙම ගත්තාම අපේ data set එකේ ඔයගොල්ලෝ හිතන්න මෙහෙම එකක් තියෙනවා කියලා. මේ 10ට අමතරව වෙනවට තිබුණා මෙතන 75ක්. මාර කේස් එක. So this 75 is very bigger than the rest of the value in the data set. අපි මේ වගේ එකකට කියනවා අපි outlier එකක් කියලා. එහෙම නැත්නම් අනිත් පැත්තෙන් තියෙනවා මේ පැත්තෙන් තියෙනවා right මේ එක වෙනුවට තියෙනවා value එකක් මේක වෙනුවට තියෙනවා value එකක් 0.001. Very small value. So these kind of values are called outliers. Inside, the range is sensitive to outliers. Because the smallest value and the largest value, right, are found at both ends of an ordered array. Right? Ordered array එක තියෙන පළවෙනි එක smallest එක, minimum එක, last එක highest එක, maximum එක. Extreme values තියෙන්නේ two ends of the outlier ordered array. එතකොට අපිට ඒක ප්‍රශ්නයක් වෙනවා. ඒගොල්ලෝ හම්බෙන්නේ එතනදි තමයි. හරි? Okay, this is it. What else? How do you solve this problem? How to solve this problem? මේ problem එක solve කරන්න කොහොමද කියලා බලන්න ඕනේ. Right? So that is the key to other measures of dispersion, which we will be talking about in our next class. අපිට තව පැය එකමාරක පන්තියක් තියෙනවා later. Right? So I need to stop the class at this point because I have another urgent meeting to attend by 11:30. And so I will have another class. ඕගොල්ලන්ට සාමාන්‍යයෙන් මම වෙන දවසක හැන්දෑවේ 8ට විතර ගත්තොත් පුළුවන්ද එන්න ක්ලාස් එකකට? සතිය දවසක පුළුවන් කට්ටිය එක දාන්නකෝ බලන්න මේ.
පුළුවන් සර්.
ඔව් 8ට විතර ගත්තොත් පුළුවන් නේද? හරි එහෙනම් මම තව දවසක 8ට විතර ක්ලාස් එකක් ගන්නවා. මේ ඒ ක්ලාස් එකේදී අපි කතා කරමු. Because I have another meeting which is started by 11:30. අපිට ඉතින් weekend එක කියලා නිකන් ඉන්න නෑ. All right. Guys, we will see you, right? In another day to discuss rest of the things. Saturday class. Okay? Right. Any question up to this? Okay, if you do not have any question, we will wind up the class. And thank you very much for attending the class, and we will see you later. Okay? Next day.
Thank you, sir.
You are welcome.